everyone. Today, I would like to give you a lesson on the topic rhombus. Before starting to watch this video, don't forget to subscribe to my channel and like it. I will be very grateful to you for that.
Diamond shapes are often found in the landscape design of parks and gardens. Here are some examples. Parc de la Villette. Part of the alleys and flower beds have diamond or rhombus shapes, creating a modern geometric design. Versailles Gardens. Classical French gardens often use diamond and rhombus patterns in flower beds and paths. Parc André Citroën. Some lawns and water features have diamond shapes for visual symmetry and aesthetics. A rhombus is a parallelogram in which all sides are equal. Here are these interesting rhombuses in front of you. Let's look at the properties of rhombus. 1. All four sides of a rhombus are the same length. 2. Opposite angles of a rhombus are equal to each other. 3. The sum of any two adjacent angles is 180 degrees. 4. The diagonals of a rhombus are always perpendicular to each other, which means that they intersect at an angle of 90 degrees. 5. The diagonals are bisected by the point of intersection. 6. Each diagonal of a rhombus is an angle bisector. That is, it bisects an angle of the rhombus. 7. The diagonals divide the rhombus into 4 equal right triangles. Let's look at the basic formulas for calculating the area of a rhombus. 1. The area of a rhombus is equal to the product of the side and the height to which it is drawn. S equals A times H. 2. The area of a rhombus is equal to half the product of its diagonals. S equals D1 times D2 divided by 2. 3. The area of a rhombus is equal to the square of the length of its side multiplied by the sine of the angle between those sides. S equals A squared times sine of alpha. I have already proved the first and third formulas in the previous lesson, so don't forget that a rhombus is a parallelogram, and I will now prove this second formula for finding the area of a rhombus p the diagonals. And so we are given a rhombus ABCD. We are asked to prove this formula. Where did it come from? So we take the triangle ABO, and remember that in a rhombus, the diagonals intersect at a right angle, so the triangle ABO will be right-angled. So the area of a triangle ABO is BO times AO divided by 2, because the area of a right-angled triangle is half the product of its legs. Now instead of BO and AO, we substitute D1 divided by 2 and D2 divided by 2, and we have that the area of this green triangle is equal to D1 times D2 divided by 8. Now we know that the diagonals of the rhombus divide it into 4 equal triangles. That is, triangle ABO is equal to triangle BOC is equal to triangle COD is equal to triangle AOD. Now we can derive the following formula, that the area of the entire rhombus is equal to the product of 4 by the area of triangle ABO, and instead of the areas of triangle ABO, we substitute what we just found, and we have that the area of the entire rhombus is equal to D1 times D2 divided by 2. The formula is proven. Problem 1. Points K and M are the midpoints of sides AB and AD of rhombus ABCD accordingly. See figure. The area of the triangle AKM is 18. Determine the area of rhombus ABCD. And so let's solve it. Here I have already highlighted this triangle AKM, whose area is 18. To solve this problem, we need to divide the rhombus into several parts. Here we have only 8 parts, and they will all be equal. Therefore, their areas will be equal to 18. So to find the area of the entire rhombus, we need to multiply these 8 parts by 18, and we will have 144. So our answer will be 144. Task 2. In rhombus ABCD, altitudes BK and BL are drawn from the vertex of obtuse angle B. See figure. The area of quadrilateral BKDL is 120. AK to KD equals 7 to 2. Determine the area of rhombus ABCD. Let's solve this problem by the condition of the problem. We have the ratio of sides AK to KD as 7 to 2. Then let's assume that KD equals 2x. Then AK equals 7x. Then let's draw the diagonal BD. And so I highlighted triangle BKD in yellow because we now have to find the area of this triangle, and it will be equal to half the area of quadrilateral BKDL, whose area is given to us. So 120 divided by 2 equals 60. So the area of triangle BKD is 60. I highlight the height BK in red. And then let's remember the formula for finding the area of a right triangle, and it is equal to half the product of its legs. So 60 equals h times 2x divided by 2. We simplify the 2's, and we have that h times x equals 60. Then in order to find the area of ABCD, we must fit the formula as we find the area of a rhombus by side and height. So SABCD equals AD times h. First, let's calculate the length of side AD, which is equal to 7x plus 2x equals 9x. Then substitute 9x into this formula, and we will have that SABCD equals 9x times h. We see x near h. We already have their product is negative 60. Therefore, we substitute instead of xh negative 60, and we have that the area is equal to 9 times 60 equals 540, and this will be the answer. It was not an easy task, but we coped with it. So if you understood everything today, I would give you Ducati Street Fighter V4 Lamborghini as a gift. If you are worried or excited because you did not understand something, no problem. Watch this video again slowly. Never give up. and I wish you to understand it as soon as possible. Bye.